In MoClo or modular cloning assembly, the location and orientation of Type IIS sites are the fundamental keys to sequential assembly. I define the Type IIS site architecture using this L notation. The vertical axis represents the recognition sequence, while the horizontal axis denotes the cleavage site and resulting overhang. In this system, orientation is absolute. The enzyme cutting 5' 3' is always positioned on the sense strand, while the enzyme cutting 3' 5' is on the antisense. These two fixed positions control the direction of the cut. In a donor vector, we place the 5' 3' site upstream and the 3' 5' site downstream. This forces the enzymes to face each other, cutting inward to release the part. In an acceptor vector, we simply swap these positions to make them face outward, opening the vector for the new insert. Overhang compatibility is mapped via color coding. Identical colors indicate compatible overhangs capable of ligation, while distinct colors denote non-compatible junctions. The MoClo workflow begins with functional units housed in level 0 vector modules. These units are ligated into a destination level 1 vector to form a complete transcription unit. Up to 6 level 1 can then be assembled into a level 2 to create multigenic pathways. To ensure only correctly assembled constructs are recovered, we rely on orthogonal selection by employing distinct antibiotic resistance markers at level 0, level 1, and level 2. Level 0 modules constitute the building blocks for higher-order assemblies. These components are typically housed in donor plasmids using an inward orientation to facilitate the removal of the backbone. These modules are categorized into functional inserts. Insert 1 is generally used for promoters, while subsequent positions are used for downstream elements. All these inserts are defined by unique overhangs. The assembly relies on sequential compatibility. The 3' overhang of a preceding insert is identical to the 5' overhang of the following one. This logic enforces linear assembly and prevents misligation. The assembled level 0 modules are cloned directly into a level 1 destination vector. In this acceptor conformation, the recognition sites are positioned in an outward orientation to ensure the vector backbone remains intact throughout the reaction. The terminal 5' and 3' overhangs of a level 0 assembly ligate with the destination vector's sites, and the orthogonal antibiotic selection ensures that only the correctly assembled transcription units are recovered post-transformation. Level 1 vector feature a double enzyme configuration, functioning as both a destination and a donor within the framework. While the 3' 5' orientation allows the vector to accept level 0 modules, the flanking 5' 3' orientation enables part excision for level 2 assembly. This nested architecture provides a seamless transition between assembly levels, allowing multiple transcription units to be consolidated into higher-order pathways. Multiple level 1 transcription units are assembled into level 2 destination vectors via two distinct methodologies. Method 1 direct assembly utilizes compatible overhangs based on the same logic described previously. In this configuration, the 3' terminal overhang of a preceding transcription unit matches the 5' overhang of the subsequent one. This sequential alignment ensures the directional assembly of the complete multigenic construct within the level 2 backbone. While Method 1 serves for fixed gene chains, Method 2 utilizes end linkers to unlock greater flexibility. This approach allows you to diversify the unit order without redesigning internal level 1 overhangs. By employing these specific linkers to bridge non-sequential units, we can reconfigure the linear arrangement of a construct on demand. This enables the rapid testing of different gene permutations. These linkers carry an orthogonal resistance marker, distinct from the level 1 and level 2 vectors. This ensures that only the final correctly assembled multigenic construct is recovered. MoClo modularity does not end at level 2. The same logic extends to accommodate massive large-scale projects. By creating a donor and acceptor configuration for level 2 vector, the system becomes cyclical. As with previous stages, the assembly is achieved through either compatible overhangs for fixed sequences or specialized linkers for modular flexibility. In my next video we will explore whether overhangs can be reused and how to select the most efficient overhang sequences to maximize assembly yield. Thank you for watching. I will see you in the next deep dive.